Hello everyone, myself Nishitha, Assistant Professor, Department of CSIT, working at MLR Institute of Technology. In previous sessions, we have discussed about CPU scheduling algorithms such as first come first serve, shortest job first, and priority scheduling algorithms and round robin. In today's session, we are going to discuss about multi-threaded programming. So let us see the overview of this presentation. In this, we are going to see about multi-threaded programming, thread and what is a thread, components of a thread and advantages of thread. So let us see the definition of thread. So thread is nothing but it is a single sequence stream within a process. So it is a single stream within a process. For each and every process, it consists at least one single thread. That is what about this single sequence stream. And threads are also known as lightweight process. So it is nothing but thread is a lightweight processes. As they possess some of the properties of processes, so it consists of some properties of their processes. So for each and every thread, it is having some property and it is also known as lightweight process. Each thread belongs to exactly one process. For every one process, it consists at least one thread. That is what each thread belongs to exactly one process. In an operating system that supports multi-threading, the process can consist of many threads. So, if it is a single process, it consists of only one single thread. But when it is comparing with multiple threads, so it consists of more than one thread. That is what each and every process in multi-programming consists more than one thread. So, it consists of many threads. But threads can be effective only if the CPU is more than one. Otherwise, true threads have context switch of that single CPU. So here, if threads can get effective only if the CPU is more than one. So CPU consists of more than one. The two threads can have context switch. Here context switch is nothing but the process which is having the process is arrived first, second is also arriving. So which one will be executing? The second one will be executing. That is what about context switch. So here in this point, but threads can have effective only if the CPU is more than one. So if CPU is more than one, the two threads have to context switch. So one after the other switch, then only the second one will be executed. That is what about this context switch. Then next see what about the components of thread. So here these are the basic components of a operating system. What are the three basic components for this thread? Stack space, register set and program counter. What is stack space here? The space provided by the processor in an LECO. LECO is nothing but last in first out. In this space, the stack can be removed from the last and it is inserted in first. So that is what last in first out, that which is the space provided by the process that can be occupied for this stack. Stack is nothing but last in first out. So register set means set of registers having to collect together. So each and every register set is allocated by partitions. So for each and every register sets, it consists some partitions and that sets have some registers. That is what register set. So next is program counter. Program counter is nothing but the process which executes the next instruction is known as program counter. In this, the instructions is followed, the instructions which is executed next, that is what about program counter. Next, what is mean by multi-threaded program? In this, a thread is also known as lightweight process. This idea is to achieve parallelism by dividing a process into multiple threads. Here, the process for single thread is divided into multiple threads. That is what dividing the single thread into multiple threads by some process. And for example, in a browser, multiple tabs can have different threads. So, if a person is browsing net, he can use n number of tabs, yes or no. See, while he was browsing net, he is listening music and in other way he is watching some videos, he is preparing one document. So, multiple tabs can do multiple works. That is what in a browser, multiple tabs can have different threads. So, Suppose MS Word uses multiple threads. So one thread to format the text, another thread to process inputs, etc. So in suppose you are taking MS Word documents. So in that one tab, in one you are doing as text, in other you are giving input. So in another one is output is you want to take that document as printer. So here multiple threads are doing multiple tasks in at a time. That is what multi-threaded program. So more advantages of this multi-threading are, multi-threading is a technique used in operating system to improve the performance and responsiveness of a computer system. So here it wants to improve its performance and responsiveness of the computer system. So whatever you are going to provide or giving a technique for the operating system, it should improve some performance and responsiveness. Next, multi-threading allows multiple threads, so lightweight processors, to share some same resources of a single process such as CPU, memory, input-output devices. So here multi-threading allows multiple threads. So multiple threads is nothing but here thread is a lightweight process and it can share the same resources of a single process. So that consists of same resources can share a only single process. So the threads which is having same resources with the same threads that can be shared with single process such as CPU, memory and input output devices. Whatever you are sharing, that may be as such as CPU, maybe memory or input output devices. So with these resources you can share the process or threads. Next, this is the diagram for multi-threaded programming. So multi-threading programming consists of single-threaded programming and multiple-threaded programming. So here single thread, how, see, let us see the diagram. See, code here given the code, data, files, registers, counter, stack. So this is what thread. So what, how the programmer is doing, sir? First he is writing some code and he is saving that data and he is creating that code. For this data he is creating one file. So after creating he should maintain some registers, the program counter, then stack. So registers are nothing but storing the files, again counter is nothing but executing the next instruction, and stack is nothing but LEC10. So all this process contains only one single thread. Why? Because it is single threaded process. So it consists of only one code, one data and one file and one register and one counter and one stack and one thread. So this is what about single threaded process. Suppose when compared to multiple threads, so here multiple threads, here you are using code, data, files. For this register, stack, counter, again register, stack, counter, again register, stack, counter. So in this multiple threads can be consists of multiple threads at a time and this can be executed at a time, whereas in single thread we are doing one single process, one thread. Here we are using multiple threads with multi-threads process. This is what the difference between single thread and multiple thread. So let us see the advantages of thread. So here the advantages are responsiveness, faster context switch and effective utilization of multiprocessor system, and resource sharing, communication, enhanced throughput of the system. So let us see the what do you mean by responsiveness. Here responsiveness is nothing but if the process is divided into multiple threads. So one process is divided into multiple threads. So each consists of some threads. If one thread completes its execution, then its output can be immediately written. So if this one completes its execution, immediately it goes to the next thread. So why? Because here the execution of the first process is completed. So until and unless if the execution of the first process it is completed only, it goes to next. That is what the responsibility of the thread. So this is what about responsiveness. Next, what do you mean by faster context switch? Here faster context switch is nothing but here context switch is nothing but the releasing of first after the second. The second will be executed first. That is what about context switch. So here context switch time between threads is lower compared to the process context switch. So it is comparing with the lowered compared of the process. So here context switch threads are released one after the other, second will be executed, and here it is compared with lower to the process by providing some context switch, and process context switching requires more than overhead from the CPU. So it requires some of the process by the CPU. It is context switching more overhead to the CPU, means one after the other, the second will be executed. That is context switch. Here the process context switching requires some CPU, whereas it does not required by the other CPU. Here next, effective utilization of multiprocessor system. So how we are going to utilize the multiprocessor system? If we have multiple threads in a single process, then we can schedule multiple threads on multiple processors. So in a multiprocessor, it is consists of n number or multiple threads. So this process have multiple processors. How they are going to schedule? So for multiple threads, it consists of multiple processes, and multiple processes can be scheduled, means the order is scheduled according to the threads, means it may contain some IDs. So according to thread ID, they can schedule their threads or processes according to the schedule time. Here next, this will make some process execution fast. So one after the other giving the schedule time, then only the execution may be faster. Otherwise, it may be getting time cast. So the worst time may be more. When the arrival time is less, the process will be executed faster. So providing some multiple threads and arranging them in schedule, arranging them in an order and getting executed one after the other, then the compilation or the execution will be faster. That is what effective utilization of multiprocessor system. Next, resource sharing. How we are going to share these resources? So resources like code, data and files. So how you are going to share your code, data, files? These are shared among all threads within a process. Here all the processes are shared within the process. See the note, stacks and registers can't be shared among the threads. Why? Because stacks and registers, why they can't be shared? By because they are they can't provide the code, data, files at a time. So whereas the code, data of the files can be among within the processes, but the stack and registers cannot be shared. Each thread has its own stack and register. So in the diagram, we have seen for every thread it is having some stack, data, code, register. So see here, for every thread it is consist of code, data, files, register, counter, stack. So that is the point here for resource sharing. It cannot be shared among the different threads. So every thread has its own stack and own register. So compared to other threads. Communication. Communication between multiple threads are very easier, as the threads share a common address space. By sharing the common address space, they can communicate very easy. While in the process, we have to follow some specific communication techniques for communication between the two processes. How we are going to communicate by connection or LAN or by network connection, or maybe communicating through mails. So how we are going to send your mails or how we are going to receive. So by providing some address space, you can communicate between two processes. That is what about the communication in multi-thread. Enhance the throughput of the system. If a process is divided into multiple threads and each thread function is considered as one thread. So here multiple threads are divided into multiple jobs and each function of the thread is considered as each job. Then the number of jobs completed per unit of time is increased. So however you are dividing the threads into number of threads and giving one each job each. For one thread each job, then the number of jobs can be completed per time may be increased. So unit of the time job completed may be increased. Why? Because we are using n number of jobs. All the jobs cannot complete at the same time. So per unit of time may be increased or may be decreased. Thus increasing of the throughput of the system. So increasing this throughput of the system. So in this session, what we have discussed: definition of thread and components of a thread, Components of thread and multi-threaded programming. Multi-threaded programming and advantages of thread. So in the next section we are going to see about the classification of synchronization. Thank you.